Greetings, pre-calc students. Have you ever thought to yourself, what's the usefulness of those sign charts? Well, here I am, ready to explain to you how useful they are. Be prepared to understand how to use sign charts for graphing purposes, as well as for solving purposes. For our first example, we're going to look at how sign charts can be useful for graphing. Notice I have a rational function, x plus 5 over x squared minus 3x, and that function is the object of my affection. I would like to graph it, but gosh, I don't know too much about it yet. The analysis that we've done already in this class includes finding x and y intercepts. This function has an x-intercept where the output is 0, but it unfortunately has no y-intercept because an input of 0 is not part of the domain. In fact, it is a vertical asymptote along with x equals 3. At infinity, or the end of this graph, we will tend towards 0. And now we ask ourselves, after we set up the skeleton of this graph, we ask ourselves, how does the function behave in between all of these critical moments? This is where the sign chart can be useful. So notice we have some critical moments at -5. The function is 0. To me, that's critical because 0 is the threshold between positive and negative numbers, and the signs that we're going to be putting on our sign chart will be positives or negatives. 0 is oftentimes a transition between positives and negatives and vice versa. But how do you know? Well, that's what we're going to be doing. We're going to be testing numbers, not really getting out of value, but more so looking at the positive or negative direction of the value. So, for example, I'm going to use the factored form of my function to do this. I'm going to test the number -8. Because it's to the left of -5, this will tell me how the function behaves to the left of -5. So -8 is my test number, and you can choose any number you would like. -8 plus 5 is a negative number. -8 is negative. -8 minus 3 is also negative. If I multiply two negatives in my denominator here, I have a positive number. But remember, the numerator was negative, so a negative divided by a positive is still negative. So I'm going to mark with negative signs here all along the bottom of this sign chart. This kind of corresponds to the graph, so what I'm noticing is that the function will be negative and approach 0 at the end towards negative infinity. Now if I test a number between -5 and 0, 0 is another critical moment because we have an asymptote there. Again, another opportunity to transition from positives to negatives. I'm going to test a different number here. I will test, -1. A -1 plus 5 is actually positive. -1 is negative. -1 minus 3 is negative. The results here will be positive. What this means is that we have positive function outputs, or y values, and so in this interval from -5 to 0, the function will increase towards positive infinity at that vertical asymptote. Remember, that's called a infinite discontinuity, so we're increasing to positive infinity there. We have 1/3 of our graph made. Congratulations. Next interval, between 0 and 3, let's pick a test number. Maybe we will test +1. +1 plus 5, yes, that's still positive. +1 is positive. +1 take away 3 is negative. So these outcomes, positive divided by negative, really gives us a negative result. Now, because there are no x-intercepts, all of these values must be negative, approaching a negative infinity at each one of those asymptotes. There's a general shape of this function on that interval from 0 to 3. If you'd like more precision, you may plot a specific point. Next interval, last interval, in fact, from 3 to infinity. Let's test 200. just to be extreme. I like to do that sometimes. 200 plus 5 is positive. 200 is positive. 200 take away 3 is still positive. Sounds pretty positive to me. Positive divided by positive is in fact a positive outcome or a positive output. Here we will approach positive infinity at that vertical infinite discontinuity, approaching positive infinity rather than negative infinity, and we will approach 0 at the end of this graph from the positive side, or above 0. And there we have it, a graph, a very specific graph. You could check it with your calculator at this time, but I feel pretty confident that we have all the major details and the sign chart filled in all of those gaps. The last application of sign charts, the usefulness of sign charts, is when we're solving an inequality. So here I have another rational function, and I am inquiring, when will this function be greater than or equal to 0? I would like to solve that. In order to do so, let us note first of all that values that are greater than 0, greater than or equal to 0, have signs that are positive. Yes, positive numbers are greater than 0. And so as I build my sign chart, those will be the results that I'm after. Outputs that are positive, the values of x that make the outputs positive. A few things to do here. We're going to find zeros. This function will be 0 when that numerator is 0, which means x equals negative 1/2 is our only 0, or x-intercept. That will be an important number on my sign chart. I will remind myself that that is 0. That should also be a solution, right? Other critical points. Is the function undefined anywhere? Or is there any domain restriction? Those are things that we would also want to make note of on our sign chart. Let's see, this function has a denominator, and if I factor the heck out of this function, we're going to see the denominator has 2 factors, which means it has 2 moments, or it will be undefined. Even a whole, ladies and gentlemen, would be a critical point in the graph, just in case we transition from positives to negatives there. So 2 new numbers that I will add to critical points are at x equals 2. Now here the function is not 0, but it is undefined, and I'm going to write a little abbreviation there, undefined. And x equals negative 2. Not part of the domain, again, not 0, but here undefined. These will not be solutions to your equation or inequality, I should say, but we will finish this by finding the behavior in between, much like we did on the graph. I will test numbers between and beyond, so here I'll test negative 3. I'm not going to go too wild. It's always best, I think, to evaluate in the factored form of the function. A negative 3 in the numerator makes a negative result. Negative 3 plus 2 is negative. Negative 3 minus 2 is negative. Those 3 negatives give me negative outcomes. I do not want negative outcomes. I want positive outcomes. This is not part of my solution set. Let's test a nice negative 1 maybe in this interval between negative 2 and negative 1/2. Testing negative 1. 2 times negative 1 plus 1 is still negative. A negative 1 plus 2, however, is positive. And a negative 1 minus 2 is negative. So here the outcomes will be positive because we're dividing a negative by a negative. Here's part of our solution set. We will continue testing to consider the whole number line, all possible values of x. Now let's test my favorite number in this interval is 0. 0 in the numerator gives us a positive 1 result. 0 in this factor is positive. 0 for this factor is negative. These results, when we divide a positive by a negative, will be negative. Again, not part of my solution set because I don't want negative outputs. I would like to know where the function has positive outputs. Lastly, we will test a number to the right of 2. Let's say 5. 2 times 5 plus 1 is positive. 2 plus 5 is positive. 5 minus 2 is also positive. Very positive, very encouraging. We have positive outputs. Positive divided by positive is positive. And look, another set of numbers to add to our solution set. And so we will write the solution in set notation, intervals if you will. -2 to -1/2 is one interval where the positive outputs, the function has positive outputs. We will not include the -2, but we will include the -1/2. Also, we will add the set of numbers from 2 to infinity, not including the 2, again because it's undefined. This sign chart has just helped me to divulge the values of x where the outputs of this function are positive. Thank you, sign chart. In summary, sign charts display the values of the function's outputs, and that is helpful to us as we try to graph. That is also helpful to us as we're solving inequalities. Those are your y values if you want to think about them that way. Knowing intervals where a function is positive or negative will help us to, in a graphical situation, see when we are above the axis or below the axis. Those positive outputs are above the x-axis. The negatives are below. And we also can solve inequalities that are greater than or equal to 0, less than or equal to 0. Doesn't necessarily have to be equal to, I guess. We could solve any inequality if we're asked about the comparison to 0, because values greater are positive, values less are negative. The only values without signs on our sign chart are the zeros, that is a neutral number, and the undefined values. They're not defined, so let's not even try to call them positive or negative. Hope you've learned how to use a sign chart and how it can be useful in more than one way. Keep learning, keep trying, you can do it. Mrs. D signing out.